basis and dimension of a subspace. Basis and dimension of a subspace. So right, let W be a subspace. Let W be a subspace of a vector space V over F. V over F. To find basis and dimension of W. To find the basis and dimension of W. These are the conditions you have to follow. First condition, from W find linear span of W. Linear span of W. Let it be beta. Let it be beta. I will repeat. From W, find linear span of W. Let it be beta. Notation beta. Second point. Check beta is linearly independent or not. Check beta is linearly independent or not. Third one, if beta is linearly independent, then beta forms a basis. In W. Fourth point, dimension of W should be equal to cardinality of beta. Dimension of W should be equal to cardinality of beta. Okay, similar conditions Dama. Okay, but here what is the first one given? From W identify the linear span of W. Because you can define only the vector space V1. And therefore subspace you are supposed to find the basis. Okay, well, you will not be given the basis anywhere. You have to find the basis for a subspace of a vector space V. So first step you have to find the linear span. What is the next one? You have to check whether it is linearly independent or not. If it is independent, it will become as a basis. Otherwise it is not. What is the third one? Last condition should be dimension of W should be equal to cardinality of beta. Okay, that is the usual condition what we discussed in our vector space. Therefore, bases are no, only the cardinalities are same. Okay, that we discussed for vector space. Here we are going to the checking for the subspace W. Okay, here in the problems when it comes to subspace, you may not be given the basis. Okay, so you yourself have to identify the basis. By which logic is that? Using the concept of linear span. Okay, here are going to the standard vectors now. What are the standard vectors? If I say R square, standard vectors will be 0, 1. Standard vectors. Standard vectors now combinations of 0 and 1 rather than what are standard vectors. Okay, if it is 2 by 2 means it will be 0, 1, 1, 0, or it can be 1, 1. But mostly we use with combinations 1 and 0. Okay, if it is a 3 dimension, what are the standard vectors? 1, 0, 0, then 0, 1, 0, 0, 0, 1. Combinations of zeros and 1. There is one more possibility is there. Okay, what is the other choices we can have? 1, 1, 0. Or it can be 0, 1, 1. Or it can be any other combination. But mostly this will be used as the standard basis. Okay, standard vectors, standard basic vectors. Okay, can you identify in your matrix now? Combinations of 1 and 0, 2 by 2 matrix. If you are now, why are you using mobile? Whatever it is. The guy that can answer message is the combination of 0 and 1. So what are the basic assumptions you can make?
1 0 0
1 0 0 0. Okay, it can be 0 1 0 0, or it can be 0 0 1 0, or it can be 0 0 0 1. Okay, this is a standard case. Why this is necessary is that here we are going to identify the basis. In some problems we take help of the standard basis to solve the problems. Okay, combination of just 0 and 1 by replacing the basis. Okay, you can understand how to write it, yes or no? Yes. So these are the sum of the standard basis which we will be using to solve our problems. Okay, shall we start the problem? So take out first one. Find the dimension. Find the dimension of. Find the dimension of the subspace. Dimension of the subspace W of the vector space W of the vector space R cube over R cube over R if W is equal to the set of elements A1, A2, A3 such that it satisfies the condition 2A1 minus 7A2 plus A3 equal to 0. A3 equal to 0. Okay, so this is entirely different from all the previous concepts what we have discussed. Okay, so what is the vector space here? R cube is given as a vector space. Okay, we are given which will become as a subspace. What is the condition for subspace? It is a triple order A1, A2, A3 with the condition 2A1 minus 7A2 plus A3 equal to 0. Only the elements which is going to satisfy this condition will come under the set W. Okay, now what is the objective? What you have to find? Find the dimension. Okay, dimensional basis more or less same procedure. By finding the basis only you can find the dimension. What is the dimension? Dimension of W is equal to, see the last one. See the fourth one. Cardinality of beta. What is beta? What is beta? Beta is the basis, ma. That is already followed, no? Yes, what is the step one you have written? We have to find the linear span. Okay, that linear span will become as the basis if it is going to be linearly independent. And what will be the dimension of W? Cardinality of beta. So, अपने नया dimension considering what you have to find? The basis. So, the first step you are going to find what is the basis of our subspace W. Okay, so in this problem, how you must think is that subspace is a part of the vector space V. Okay, where the number of elements will be same or different? Different. It will be lesser or it will be greater or it will be equal. Now, my subspace na original space oda number of elements kammiya irukkum adhigam kammiya irukkum. Okay, the logical method nyabam vechukko. Edhu is important na when you find the basis, we are going to reduce it to be a very smallest possible basis. Okay, so now when you see R cube means what is the dimension ma? 3. Okay, we can't say that dimension of basis also will be equal to 3. That is not right because we are trying to find a subspace, correct subspace. So for subspaces, the number of elements may be lesser also. So you must try to find the basis by reducing it to a very smaller number. For that purpose only these conditions are good. The condition would be the reason around. So in that, as it is for the how many variables are there? 3. But we are trying to find the basis, we must reduce to this to minimum number of variables. Okay, for that purpose only these extra conditions are given for you. How can you reduce? Can you reduce this to 2 variables? Possible or no? Originally our vector space is having 3 variables. Is it possible to reduce it to 2 variables? Yes. According to this condition, you can find A3 in terms of A1, A2. If you replace it means every variable will be only in terms of A1, A2, only 2 variables. Clear that? And A3 we can find A2 or you can find A1. Anyway, we can reduce this For that reduction procedure only, this condition is given. Okay, in some problems it will be possible for us to reduce only one variable. In some problems it may be two variables according to the given condition. Okay, என்ன condition கொடுத்துருக்காங்கன்னு பாரு. அது எந்த அளவுக்கு number of variables replace பண்ணி உன்னால number of variables reduce பண்ண முடியுமோ அந்த அளவுக்கு அந்த conditions மாத்தி வெச்சு. Then only you must start finding the basis. Okay, so start the solution. Given, write a W. Set of all elements A1, A2, A3 such that 2A1 minus 7A2 plus A3 equal to 0. Plus A3 equal to 0. Tell me what I explained you now. Yes? Repeat, ma. You said you are listening to the class, right? What you have to do, ma? First you have to find the linear span. That we will be having a beta. So how will you prove it? L of beta is contained in or equal to V. V is contained in or equal to L of beta. Therefore L of beta equal to V prove panna. But here do you have a beta? No, we have to find the beta. Using the same linear concept, we are trying to find what will be our beta value. Okay, வாங்க பீட்டா கொடுத்ததுனால அப்படி ப்ரூவ். இந்த பீட்டா உனக்கு தெரியாது. ஸோ அந்த லீனியர் ஸ்பேன் லாஜிக்கை வச்சு பீட்டா என்னங்கிறத நம்ம கண்டுபிடிப்போம். வாட் இஸ் த மீனிங் ஆஃப் லீனியர் ஸ்பேன்மா? Any element in V will be written as a linear combination of set of elements, which will be our beta. That is linear span. And the logic we use பண்ணி we are going to find what will be our V1, V2, V3, etc. அங்கே முன்னாடி டாபிக்ஸில் V1, V2, V3 கொடுத்துருக்கோம். இங்கே கிடையாது. இந்த கான்செப்டை யூஸ் பண்ணி we are going to find what is V1, V2, V3. So here one thing you must reduce it as minimum number of variables as it is possible, because we are trying to find it only for a subspace, not for a vector space. Okay, so right, have you written the first step? W equal to, yes, right, 2A1 minus 7A2 plus A3 equal to 0. Write the given condition. That implies A3 equal to minus 2A1 plus 7A2. So here no other reduction is possible, so we are stopping with only one variable. Right? Let V belongs to W. Let V belongs to W. So we are going to consider an element in our subspace W, and we are going to show that it can be written as a linear combination. Okay, so right, let V is equal to A1, A2, A3, because that is the form how we have defined W. In W, all the elements will be of the full order form A1, A2, A3. Right, next line. Therefore, A1, A2, A3 will be equal to A1 plus A2 plus A3. Okay, what you should try to do? This elements can be written as a linear combination of some other elements, which is going to be our basis. We don't know what is that one, so we are going to make use of our standard basis which I told you. This is a triple order. So what is the standard basis? 1, 0, 0, 0, 1, 0 and 0, 0, 1. Because we don't know what is the basis, so we are going to take the help of the standard basis. Okay, so right. So A1 into 1, 0, 0, A2 into 0, 1, 0 plus A3 into 0, 0, 1. But already we found out A3 in terms of A1, A2. So replace that one. A1 into 1 0 0 plus A2 into 0 1 0 plus what is A3 minus 2A1 plus 7A2 into 0 0 1. So now we must try to simplify this and write it as a combination of A1 and A2. Okay, because we are trying to find the basis one, it should be of minimum number of elements. So only we have converted A3 in terms of A1 and A2. Now normal simplification and rewrite this as a linear combination of A1 A2. Okay, how can I do it? Multiply A1 inside, what will happen? A1 0 0 plus 0 A2 0 plus split this into two terms. This one into this one plus this one into this one. So what will happen? 0 0 minus 2A1 plus 0 0 7. Just normal simplification, nothing complicated. Now combine the terms of A1 A2 because we are trying to relate it as a linear combination. So combine all the terms with A1. Don't add everything, need it as a linear combination, not as a final answer. So it should be a linear combination of A1, A2, etc. Because we are trying to find the basis. So combine the corresponding elements. Add A1 terms, what you will get? A1 0 minus 2A1. Add the corresponding elements. A1 plus 0, 0 plus 0, 0 minus 2A1. Now add the elements of A2. What you will get? 0, A2, 7. Okay. Now take A1, A2 as a common term outside, it will become as a linear combination. So this is equal to A1 into 1 0 minus 2 plus A2 into 0 1 7. So what is it? A? You are going to write the given element in W to be a linear combination. Okay, there we try to reduce it as a very smaller number because we are trying to find the basis for a subspace. Any other simplification is possible now? No. So we stop here and these two elements will be the basis. Okay, so what will be the basis for us? Not a basis, we have identified beta. Okay, what we have beta say? 1 0 minus 2 and 0 1 7. How many elements it is going to have? 2 elements. So originally Rp is having how many elements? 3. Now we have reduced it to be 2. Why? Because of that we are trying to find it for a subspace. Okay, so right. Let beta equal to, let's say 1 0 minus 2 0 1 7. Whatever vectors you get here, that will be our beta. Therefore, L of beta is equal to W. Can you say or no? W is an element in, so this is an element in W. We were able to write this as a linear combination of beta. So it spans our W. L of beta equal to W. First part is over. We identified what is beta. When it will become as a basis? Only if it is linearly independent. Now we have to check whether beta is linearly independent or not. So right? To check beta is linearly independent or dependent. To check beta is linearly independent or dependent. You are over that condition now? How many elements in beta? 2. How do you prove it for independent? In a condition for independent. Independent check பண்ணுங்க. What is the equation you assume? A1 B1 plus A2 B2 should be equal to 0 or alpha 1 B1 plus alpha 2 B2 should be equal to 0. It will be as an independent if all the alpha are 0 or not 0? 0. If at least one alpha is non-zero, then it is said to be dependent. Just general condition for dependence and independence. How we are going to check it now? What do you have to do this one? Multiply alpha and combine. So if you multiply alpha and combine, what you will get? What is the answer? Alpha 1, alpha 2, minus 2 alpha 1 plus 7 alpha. This is equal to the 0. So if we equate the terms on both sides, what you will get? What you will get, ma? Obvious one. Alpha 1 is 0. What about alpha 2? That is also 0. Equating the terms on both sides. So both the alpha are 0. Dependent or independent? Independent. So right. Therefore, beta is linearly independent. Beta is linearly independent and forms a basis of W. Beta is linearly independent and forms a basis of W. Forms a basis of W. What is the main objective to find, ma? Dimension. So what is the dimension of W? What is the fourth condition, ma? Dimension of W should be equal to cardinality of beta. What is cardinality of beta? How many elements are there in beta? 2. So what is cardinality of beta? 2. So what is dimension of W? 2. So right, final conclusion. Hence, dimension of W, which is equal to cardinality of beta, is equal to 2. Dimension of W equal to cardinality of beta is equal to 2. Any doubt in this problem? Can you understand the procedure? So first step, what you are going to do? You are going to assume an element in W. Okay, we must try to find it, write it as a linear combination of some set of elements. In that process, you must reduce the number of variables as far as possible. Okay, that will become as the set beta. Next, you have to check whether it is independent or not. Okay, if it is independent, it is going to be a basis. If it is a basis, then dimension of W will be equal to cardinality of beta. Okay, dimension na kandupidikra adha your procedures. Okay, any doubt? Shall we proceed to the next one? Yes, sir. So take the next one. Determine the basis and dimension. Determine the basis and dimension of the solution space. Basis and dimension of the solution space of the linear homogeneous equation. Solution space of the linear homogeneous equation x plus y minus z equal to 0, minus 2x minus y plus 2z equal to 0, minus x plus z equal to 0. So everything deals with basis and dimension only, but each one will be a different concept. First problem what we found out? Base, the dimension for a subspace. Here what you are supposed to find? Basis and dimension of what? Solution space. Okay, you know this is a set of equation. Homogeneous or non-homogeneous? Homogeneous. This is going to have a solution. We have to find the basis for that set of solution. Okay, well, so what you have to find? The basis for the solution of this homogeneous equation. For that, you should know the nature of the solution. We discussed solid homogeneous and non-homogeneous. Yes or no? What are the types of solutions possible? Unit solution, infinite number of solution, no solution. So using that logic, first you have to check what type of solution is going to exist. Okay, well, any solution தெரிஞ்சதுனால அதோட basis என்னங்கிறத நம்ம கண்டுபிடிக்கணும். Okay, do you know how to check it? Yes, tell me. Yes. You have to consider the matrix E. Then using determinant concept also you will discuss. Do you remember that? Determinant in the solution. Boys, இன்னும் கூட வந்து ஞாபகம் இல்ல யாமே வாய் தர முடியல. The determinant but you discuss the solution now. I am asking that condition. You are over it. Determinant equal to 0. X equal to 0. Solution बराबर है ना? Why unique solution? Right hand side 0 आता है ना unique solution करेगा. Determinant 0 आता है ना non-zero आता है ना. You are over it. Say this is the last topic, but it is combining all the topics what we have discussed in our unit 3. Yes or no? So only if you know all those concepts, you can solve this last topic. This last topic is a very important topic for you, according to math subject as according to as well as your department subject. How to find the basis and dimension. So you should cover the entire unit mark. Then one you can solve the problems under this last topic. Okay, start the solution. Given, write the given equations. What are they? Right. Write the given equations. Okay. Then you write the matrix A based on the given equations. What is the matrix A? 1, 1, 1, minus 1. Next. Minus 2, minus 1. Last one. 0. Okay. This is your corresponding matrix A. The coefficient matrix. Identify the determinant. Identify the determinant. Determinant of A. Determinant of A. Others? Everyone getting 0? Sure? Last bench. What is the determinant? 0. If the determinant is 0, what type of solution? Non-trivial. Okay. Rpla unique, infinite, no solution. It will be having an infinite number of solutions. Okay, right. Right. Next line, determinant of A equal to 0. Therefore, the given system of equations have infinite number of solutions. Given system of equations have infinite number of solutions. Infinite number of solutions. What is the next step is that you must try to find here variables. What is x, what is y, what is z. Even though it is infinite, you must try to find that one. Infinite number of solutions. Okay, how can we find now? Back substitution. What is the last equation? Minus x plus z equal to 0. From that what you can say? X is equal to z. Here you can't find it as a value. Okay, it is not possible for us to find it as a value. We can represent it only in terms of an unknown variable. And infinite number of solutions. Infinite number of solutions solution in terms of an unknown variables. We know that x is equal to z. So let us assume that x equal to z is equal to some constant. Because it is going to have infinite number of solutions. Now try to find what is y. Y is 0. Right? X equal to k as well as z equal to k. Both cancel, so you will get y equal to 0. So what is the solution space or solution set? What is the x value? K. Z value? K. And y value is 0. So what is your solution set? K, 0, k. This is your solution set. Okay, the possible solution. It is going to have an infinite number of values. So what is our solution set? X equal to k, y equal to 0 and or the basis. Okay, what can you understand? Try to solve it. Identify is going to be finite solution or infinite solution. Anyway, we will be having a solution set like this. It may be finite or infinite. Try to eliminate the common terms and try to reduce it as far as possible. That set will become as our basis. Okay, so right. Let beta equal to, let's say, 1, 0, 1. We have identified the set now. Okay, now we have to check whether it is a basis or not. How do you do it? Basis now, what is the condition? Linearly independent. But here how many elements are there? Only one. Any set with only one element is always linearly independent from it. ஏனா அது டிபெண்ட் பண்ணனா கூட ஏதாவது ஒன்னு இருந்தா தான அதோட டிபெண்ட் பண்ண முடியும். Yes or no? That is the meaning of dependent. Dependent means what is the meaning? One depends on the other. Here it is only a singleton set. It is not going to depend on anything else. So any set with one set of element is always an independent one. Right? Any singleton set is always independent. Any singleton set is always independent. SINGLETON. An element with one single element, that is called as a singleton set, is always independent. Therefore, beta is a basis. So what is the main objective you have to find now? Dimension of that solution space. That will be equal to the cardinality of beta. What is cardinality of beta? 1. Okay, so what is the dimension of the solution space? 1. So the final conclusion is dimension of solution space is equal to cardinality of beta, which is equal to 1. Cardinality of beta, which is equal to 1. Any doubt, ma? Any doubt? Yes? So like this, the problems may be based on the matrices also. Same similar concept you have to solve. Okay, matrices means what is the general basis you will assume? 1, 0, 0, 0, then 0, 1, 0, 0. Like that you have to assume and show that it is going to be a basis. Okay, any doubt under this topic? Still we have one more concept to discuss. With that, the unit will be over. Again based on the subspace. Any doubt under this topic? Yes or no? No. Shall we proceed with the next one then? Yes? Wait. Of subspace W of V generated by given set of vectors. Take note. Let W be a subspace. Let W be a subspace of a vector space V over F generated by the given set of vectors. To find the basis and dimension of W. So now the following thing is the procedure you have to follow to solve in the problem. First point. Let A be the matrix of the given vector. Second one, reduce A reduce A into echelon form. What I told you about what is echelon form? Make as many elements as 0. Okay? Reduce A into echelon form. Let, continue the same. Let beta be the non-zero rows. Let beta be the non-zero rows. Next step. Beta forms a basis in W. Beta forms a basis in W. Next one. The basis of B is beta union beta dash. Beta union beta dash, where beta dash contains cardinality of dimension of B minus cardinality of beta, cardinality of dimension of B minus cardinality of beta elements from the standard basis of B, comma, which is independent to beta. So you can have this as another procedure for finding a basis. Here what is the procedure given? You have to write the given vectors as a matrix A. Then you must try to reduce it to an echelon form. That is, make as many number of rows as 0. That is our echelon form. The number of non-zero rows will be there, no? So the set of the non-zero rows will become as the basis. That's all. Okay? So the set of non-zero rows will become as the basis. No need to check for independent also. If you go by this method. So there is another procedure for finding a basis. But what is the next step we given? Beta union beta dash. Will be asked to find a basis of one subspace. Based on that one, you extend it for an entire vector space. In that case, you go for the last step. What is the last step? Beta union beta dash. Beta will contain the elements of non-zero rows. Beta dash will be the corresponding standard vectors. Already told you what are the standard vectors. Now you have to combine them. Okay, when you write it as a combination of both, you will get the basis for the original vector space. Okay, complicated very simple one. And the first part you can make use of as an alternate method for finding the basis. Okay, so start with the problem. First one. Let W be the subspace. Let W be the subspace of R4. W be the subspace of R4 generated by the vectors. 1 minus 2, 5 minus 3. 2, 3, 1 minus 4. 3, 8 minus 3 minus 5. R4. Find a basis and dimension of W. Find a basis and dimension of W. Full stop. Extend the basis of W. Extend the basis of W to a basis of whole space. To a basis of whole space R power 4. Whole space R power 4. So the first part is the same thing. You are given W to be the set of elements defined like this. You are defined the basis and dimension of this W. Here we are going to take the help of our matrix reduction concept. Okay, previously solved by many methods. Here we are going to go for the matrix reduction. What is the step one you have to do? Step one in. Just now I gave the procedure. No, write it as a matrix A. So start the solution. Let A equal to. Write the given vectors as a matrix form. 1 minus 2, 5 minus 3, 2, 3, 1 minus 4, 3, 8 minus 3 minus 1. No need for any intermediate steps, write it directly as a matrix form. You are going by the procedure now, reduction procedure. What is the step 1? The help of first element, make all the remaining elements 0. Next, second row, second element. Then, third row, third element. Now we will stop up to that part. Okay? Only for 3 elements you will. Okay? And in our first element, you can make use of. Second element, you can make use of the 3 element. Can you take the third row, third element? In the perfect logic, it will work out. In that case, what you do is that go for some general transformation. Okay, and make as many elements as you. For target in you must try to make many number of 0 rows. 0 rows means what is the meaning? Full. The row you must say 0 full. That is standard transformation work out because it is a non-square matrix. Okay, square matrix means you can follow that logic. Okay, non-square is go for any other transformations also. One in the register go. You have to check it whether there is any other transformation to make the numbers to be 0. As far as possible, you make many rows to be a 0 rows. Then only you must stop your transformation. Don't stop with the standard transformation. Apart from that one, you must try to think of a transformation to make more number of elements to be 0. Okay, because what you are trying to find the number of non-zero rows. Here we solve solution and we try what you are trying to find number of non-zero rows which will become as the basis. So here the target should be is that make maximum number of rows to be 0. Okay, so after final transformation, what is the transform matrix? It is that 1 minus 2, 5 minus 3, 0, 7 minus 9, 2, 0, 0, 0, 0. Already solved many problems based on transformation, so I am skipping those steps. This is the finalized transform matrix. Note it. No. Transformation produces the correct finalized matrix should be this one. So how many non-zero rows are there? How many non-zero rows? 1 or 2? 1. How many non-zero rows? 2. These 2 are non-zero rows. 0 row is what is the meaning? All the elements should be 0. Even if one element is non-zero, that is a non-zero row. So how many rows? 2 rows. So this 2 will become as the set of elements for our basis. So our basis beta is going to have the set of elements of the form 1 minus 2, 5 minus 3 and 0, 7 minus 9. So this will be our basis. That's all, very simple. Okay, so right after the matrix, right, the non-zero rows forms a basis of W. The non-zero rows forms a basis of W. Therefore, beta equal to, write the non-zero rows 1 minus 2, 5 minus 3, 0, 7 minus 9, 2. Forms a basis of W. So first part is over. You got the basis. What is the next one? You have to find dimension. How do you find dimension of W? Then the first part is coordinate of beta. So what is coordinate of beta? 2. So dimension of W equal to 2. So right. Dimension of W equal to coordinate of beta is equal to 2. So first part is over. You have got the basis as well as the dimension. Even if you have possible means you can solve the previous problems by this procedure also. Your choice. There is another way of finding the basis and dimension. Okay. What is the second part of the question?
Extend the basis.
Extend this basis to. Here this is the basis for W. Let extend this for whole space R power 4. Okay. It is R power 4 now. So how many elements in R power 4? 4. The basis should contain 4 elements. Already this basis containing how many elements? 2. So you have to include 2 more elements. That 2 more elements will be your standard basis. Okay, what is standard basis? On the board I wrote it for 2 coordinate as well as for 3. This is 4. What will be that standard basis? 1, 0, 0. 1, 0, 0, 0. What is the next one? 0, 1, 0, 0. Third one? 0, 0, 1, 0. Last one? 0, 0, 0, 1. This is going to be the standard basis for R4. Okay? We need the third and fourth element. So consider these two and combine. That will become as the basis for the entire vector space. Okay, already 2 elements இருக்கிறதுனால இந்த standard basis தான் இந்த எலிமெண்ட்டை சேர்த்து போட்டு that is the basis we consider. Why we are assuming the standard basis is that because it will be always linearly independent. ஏன்னா பீட்டாவோட important condition என்ன? It should be independent. நம்ம ரேண்டமா ஏதாவது நம்பர் போட்டோம்னா it may not be a linearly independent one. So only we get the help of our standard basis which is always linearly independent. Is that clear now? Yes. So write the conclusion. Right? Dimension of R power 4. Dimension of R power 4 is equal to 4. Is equal to 4. Therefore, the dimension of R power 4. Dimension of R power 4 must contain 4 elements. Must contain 4 elements. So that the set write your standard basis form. 0, 0, 0, 1. We need only 2 elements. The set 0, 0, 0, 1, comma, 0, 0, 1. The last 2 elements because we need only 2. Now standard basis is the we are taking the last 2. Okay? Yes. Independent of the elements in beta. Is independent of the elements in beta. This set is independent of elements in beta. Therefore, basis of B is equal to combine beta and beta dash. This is your beta dash. Hence, the basis of B is equal to beta union beta dash, which is equal to. Just combine both and write the 2 elements of beta, comma, the 2 elements in beta dash. So this is the basis of B. We need not find it separately using the subspace.